Good morning, good afternoon, good evening, ladies and gentlemen, and welcome to part 2 of this lesson. So, in part 2 of this lesson, we're going to be starting now to talk about angles that are greater than 90 degrees. Okay, so for angles greater than 90 degrees, you can actually use the unit circle as a guideline to determine the value of the angles. So notice myself a typo there, the angles. Fun times. So, quadrant 1, so they go counterclockwise, so this is quadrant 1. Okay, which happens between 0 degrees to 90 degrees. Okay, this is quadrant 2, which happens between 90 degrees to 180 degrees. This is quadrant 3, which happens between 180 degrees to 270 degrees. And finally, this is quadrant 4, which happens between 270 degrees to 360 degrees. Okay, so those are your 4 quadrants. So no matter where your line ends up, that is the angles that determine that area. Okay, so let's take a look at how these examples work. Okay, so for this example here, we're going to be looking at it. It says point -3 and 2 is on the terminal arm of angle theta in standard position. So they want you to find the value of theta. So when it comes to these type of questions, if you have trouble understanding the way this looks, it's better to draw it out first. So your first step should always be draw it out. It doesn't have to be very detailed, it's just enough that you can be able to see what it looks like. So basically, you have yourself this mini grid. That's your x, that's your y. I know my point is supposed to be at -3 and 2. So 1, 2, 3. It's on this side because it's -3 and 2. 1, 2. Which means, connect this. This would be my terminal arm. Okay, so if that's my terminal arm, then you go from here. This is your initial arm. Remember, you connect all the way up to here, and that would be my theta. Okay? So clearly, my theta is inside quadrant 2, which happens between 90 degrees to 180 degrees. Okay? So that's your first step. Your second step is you want to find out what is your relative acute angle. Which we gave it that nice little colorful symbol. Okay? So that angle, well, how do I find that out? Well, let's take a look. If I'm trying to find this angle here, let's keep on with, let's go with yellow here. So I'm trying to find theta. Okay, which means the first thing you need to have to do is finish your triangle. Okay, obviously this is going to be 2 because that's my y. This is going to be 3 because that's my x. The negative value is not really necessary here, so you don't need to use it, mainly because you're using a squared plus b squared, so no matter what, it's going to turn into a +3. Okay, so at this point, a lot of people would end up trying to do Pythagorean theorem and finding out what my r is and wasting some time. In reality, in this question here, they're only asking you what is theta. They want theta. Okay? To find theta, you're going to need to find out what your relative acute angle is. You don't actually need r to find out what this is. You just need to use SOHCAHTOA with something that you have. So what do I have in front of me? Let's look at what we have. We have the 3, we have the 2. What are these? Well, this, in relationship to my acute angle here, is the adjacent. And that's the opposite. So out of all of SOHCAHTOA, what uses adjacent and opposite? Well, SO uses hypotenuse, Ka uses hypotenuse, so I cannot use SO or Ka, which that just leaves me with TOA. Okay? So that means I can say tan of my acute angle is equal to opposite over adjacent, so 2 over 3. If I want to find out what the angle is, you have to do tan inverse 2 over 3, which will give me about 33.7 degrees. So that is what this angle should be. Okay? So now if you want to find out what theta is, okay, so that's your second step. Third step is to find theta. You would take that angle that you just found, you want to take it away from the maximum of the quadrant. So if it happened to be in this quadrant, you would take it away from 270. If it happened in this quadrant, you take it away from 360. If it happened in this quadrant, well, you don't need to do anything because it's already between 0 to 90. Okay, so it's in quadrant 2, so we're using 180. Alright, so I know that it's 180 minus 33.7, which should give me a final answer of about, again, we're using about because we rounded initially, 146.3 degrees. So that is my theta. Okay, so let's put up another example and have you guys try that out. Okay, so for this example here, it's the same wording as the other example, so I didn't write the full wording, but basically it's supposed to say that the point, and it's two separate questions here. These are the 2 points, and they're both on the terminal arm, and the angle is in standard position. Find the value of theta. So I want you to pause it at this point and try the steps yourself here. Okay, I'm assuming you're all back. Welcome back. So let's take a look at how you do this. So once again, we're following our steps. So our first step was to draw it out first. Okay, so we're going to draw it out, get a picture of this. So -2. And 1, 2, 3, 4, -4. Okay, so my point's there, which means this is where my line is. That's where my line is. That means my theta goes all the way around here. That is my theta. So this is quadrant 3, which we know is between 180 to 270. All right, so with that in mind, once again, you want to complete your diagram here. So complete triangle. Why do I need to complete it? Because you need to find out what this is. Okay, because that's your acute angle. So if I want to find that out, well, what can I use? Can I use sine? Nope, I don't have my hypotenuse. Can I use cosine? Nope, I still don't have my hypotenuse. So the only one I'm stuck with here is, of course, tangent. So it's going to be tan of gamma, okay, is equal to, well, I know that this is 2, this is 4. Again, negative values don't matter because they get squared. So you're going to have 4 divided by 2. That's opposite over adjacent. So gamma is going to be tan inverse of 4 over 2, which is approximately 63.4 degrees. Don't forget your units, guys. And of course, now you're going to be doing that angle. Now, in this case here, this would be a different situation than what we saw before. Now, in the last slide, I told you you want to take the maximum and you want to take it away from the maximum of your quadrant. Now, the reason that worked when you were looking at quadrant 2 was because when you think about it, your alpha, your gamma is going into the quadrant. So it's not using the full quadrant, it's only using a part of it. So if I want to find out what it is inside it, I need to take it away from 180. But if you want to figure out what this angle is, well, this angle happens after 180. So because it happens after 180, you would add it to 180. Okay? So you want to add it to 180. It's happening after 180. So let's write it. So I'm going to have 180 plus 63.4, which is going to give me 243.4 degrees. Okay? So let's see what happens here. Now, over here, let's draw it out first. Okay, so if I'm drawing it out, I've got 2 and negative 3. So 1, 2, 1, 2, 3. So this is my line. So that's my line. Once again, this is going to be my gamma. All the way to here is going to be my theta. Okay. And once again, you want to complete this whole line again if you want to complete this. Okay, so you know this is going to be 2, this is going to be 3. Again, negatives don't matter. You can only use a tan in this situation. You're going to find that to be a common trend here. So tan. Well, that's going to be opposite, which is 3, over adjacent, which is 2. Which should give me approximately 56.3. Okay, so if that's approximately 56.3. Now, in this case here, this is another kind of situation. All right, so in this situation here, would I add it to 270? Would I subtract it from 360? You're going to find that in this case, you would subtract it from 360 because the angle is happening below. Okay? So, in this case, you would do 360 minus 56.3, which is going to give you 303.7 degrees. So that should create actually some set of rules that we can follow when it comes to when we add and when we subtract. So basically the set of rules are this. If it's in quadrant 1, I don't care. It's going to be whatever angle it is. Theta is theta. In quadrant 2, theta is going to be equal to 180 minus gamma. Quadrant 3, theta is going to be always equal to 180 plus gamma. And quadrant 4 is always going to be theta is equal to 360 minus gamma. Okay, those rules work every single time. If you're wondering why those rules work more, please talk to me about this. And but if you do know, please let me know. I want to actually hear your impressions. Why do you believe this is true? Okay. Okay, so let's just do a quick summarization of what we learned up until this point, and that's basically for any angle theta in standard position with point xy on the terminal arm, and r is equal to the square root of x squared plus y squared. If I want to find out what my primary trig ratios are, I know that sine of theta should be y over r. Cosine of theta should be x over r. And tan of theta should be y over x. Okay, that works every time. Show you here in the graph. Okay, so you got your line. okay, which is your point usually. You have your theta. You know this is your x, this is your y, right? And of course, this is your r. And if you continue this, this is your y. Okay? So, this also leads us to another thing we could talk about, which is something called cast. So, let me show you what this means. So basically you're going to go here. So, what cast is, and this is basically something that shows you in which quadrant that they are positive in. So basically, so S So what this means is that in the first quadrant, sine, cosine, and tan are all positive values. Okay? So your final answers are always going to be positive there. Over here, this means that only sine will be positive, which means, of course, cosine and tan will both give you negative answers. And it makes sense because we know in this quadrant here, it's made up of positive and positive x's and y's, which means you're going to have positive divided by positive, positive divided by positive, positive divided by positive, so you're going to get positive answers. Over here, on the other hand, you're going to have a positive y and a negative x, which means sine is definitely going to be positive because they're both positive answers. But cosine has x there, which would be negative divided by a positive, which is going to give you a negative answer. And same thing here, you're going to have a positive y and a negative x. Next up, you have the third quadrant where only tangent is positive. Once again, this makes sense because you're going to have a negative x and a negative y, which means over here you're going to always have a negative divided by a positive, a negative divided by a positive, negative divided by a negative, which will give you a positive. And finally, in quadrant 4, the cosine is going to be positive, which means that's because you have positive x, negative y. So the negative y will make the sign negative here, but here there is no y, which is why it will be positive. Yes, I know I just said y multiple times. Now, how is this useful for me? Well, we're going to see how this is useful in the next example. Okay, so let's take a look at this one here. So in this example here, they're giving you a graph, they're telling you what the terminal arm is, and they're giving you the points. So they want you to determine the exact values of the trig ratios, okay? Now, which one out of them would be positive? Well, this is happening in quadrant 3. So I know the tangent value is going to be positive. Okay, so let's calculate these. So I know that sine of theta is going to be, well, first and foremost, you actually need to find your r here because we didn't find our r yet. So first step, obviously, find your r. Okay, so obviously this is -4, this is -3, so going to need to do Pythagorean theorem, which you remember the theorem from earlier should have -4 squared, or 4 squared, which is going to give you 16, plus 3 squared, which is 9. So that gives you square root of 25, which is 5. Okay, so we know this is 5. Alright, so now that I know this, I can do my sign, because my sign is going to be y over r. So that's going to be -3 divided by 5. I also know that cosine of theta is going to be x over r, so that's going to be -4 over 5. And finally, tangent theta is equal to, well, we know this is going to be our positive answer here, so because you're going to have negative 3 divided by negative 4, which is positive 3 over 4. So in this one here, now remember, key word here, exact. When I tell you exact, that means I need the final answer to be in fraction form. Okay? Okay, so let's finish this off and look at 2 more quick examples. Okay, you'll see that this example is a different type of example, where now instead of giving you the point, I'm giving you the actual numbers. Now, most people will try to use their calculator and just do sine inverse of 210 to get them a decimal number, but remember, this question is asking you to find the exact value, so I want them in fractions. Now, in order to do that, you need to figure out what is that 210. And the only one to figure that out is you need to figure out what the angle is actually in quadrant 3. Because 210, this happens to be in quadrant 3. So what you need to find is you need to find what your actual gamma is. So your first step in these type of questions is to find gamma. Okay? So let's find this out. Well, I know I have here 210. I would subtract 180 from it so I can figure out what my angle is, which would give me 30 degrees. And obviously this is in quadrant 3. Okay? Now, if I'm looking at sine, now I'm remembering my cast system. And cast told me in quadrant 3, only tangent is positive. So when I'm doing this calculation, this now turns into negative sine of 30 degrees, because I know my final answer should be negative. Okay? And of course, sine of 30, well, 30 degrees is one of our special triangles, and we know before that sine of 30 should be 1 over 2, which means I should have negative 1 over 2. Okay? So just annotate a little bit more steps there. So your second step, as you can see there, we have to use cast. Or not. So obviously if this happened in quadrant 2, I would not need to put a negative there. Okay? And of course your third step is you're using special triangles to figure out your answer. So in question 2, I want you guys to try out B and C. Pause it for a quick sec. Okay, welcome back. So part B, let's take a look here. So let's follow our steps. So first step, well, you're going to do 360 minus 315, which is going to give you 45 degrees. So it's 45 degrees in quadrant 4. Okay, so if it's quadrant 4 and I am looking for cosine, well, I know that cosine is positive in quadrant 4, which means I can say this is the same thing as saying positive cosine of 45 degrees. Now, 45 is one of our special triangles, so once again, I should know that the cosine of 45 degrees is root 2 over 2. And you're done. And part C. So in part C, you got tangent. So what are we working with here? We got tangent, so let's go our first step again. So we're going to do 180 minus 120, which is going to give you 60 degrees. So you're going to be left over here with tangent of 60 degrees in quadrant 2. Now, if it's in quadrant 2, well, only sine is positive there, which means this should be negative tangent of 60 degrees. Okay, and tangent of 60 degrees, once again, 60 is one of the key ones we learned, should be root 3, but it's in quadrant 2, so it's negative root 3. Okay, so let's look at our last example. Okay, so let's continue here with our last example. So first and foremost here, I'm asking you if 0 is less than or equal to a, which is less than or equal to 360. I want you to find the possible measures of angle A. It's basically what this is telling you here is that my angle of A is going to be between 0 and 360. It's not going to be bigger than that, or smaller than 0, obviously. So, first thing you should notice is this negative here is not needed when we need to solve our angles. Mainly because this negative is mainly just telling me the position of where my angle is, not what the actual angle is. Okay, so you don't need to worry about it right now. Okay, so the first thing you want to do here is you want to find out. Okay, so your first step is to find out what your angle is, and to do that you don't need the negative. You just need to say that, well, my gamma, and I know my gamma is going to be the tan inverse of root 3, which is actually 60 degrees. Now, this negative then here is telling me that tangent is negative, which means that only happens in quadrant 2 and quadrant 4. So you're going to have two possible answers here. One if it's in quadrant 2 and one if it's in quadrant 4. So if it's quadrant 2, then you know that your answer should be 180 minus gamma, which should be 60 degrees. If it's quadrant 4, it should be 360 minus 60, which is 300 degrees. Okay? So those are your two possible answers for A. So pause it right now and try to do the same thing for B. Okay, welcome back. So for B, you have a little bit of an added step here, and that's mainly because you're working with cosecant. So cosecant, you need to turn it into, obviously, 1 over sine. Okay? So if you're going to turn it into 1 over sine, you're going to be flipping your two things. So basically sine of A, and you guys can see that in the first lesson that we looked at, should be 3 over 2 root 3. Okay? Now, I know we don't like radicals on the bottom, but you don't have to worry about it right now because we're not looking at final answers. So now that I know that, well, now you follow the same steps we did before. So the same steps we did before, you're going to have gamma is going to be sine inverse of 3 over 2 root 3. Again, you don't care about the negative right now, which is going to give you 60 degrees. Okay, now you care about the negative. The negative tells me what? We're talking about sine here. Sine is only going to be negative in the third and fourth quadrant. So you have two possible answers, third or fourth quadrant. So quadrant 3, quadrant 4. So quadrant 3, you're going to have to do 180 plus gamma, so you're going to do 180 plus 60, which is going to give you 240 degrees. Or quadrant 4, which means you're going to have 360 minus 60, which is going to give you 300 degrees. Okay? I hope that has helped answer any of your questions in terms of concepts. And if you have any questions, please let me know. Have a good day.